here in chapter 2, our goal is going to be to learn pretty much everything there is to know about polynomials and their graphs. So we're going to start that off today with monomials. And monomials are, of course, a polynomial with just one term. So if we have a monomial, we often refer to those as a power function. So we have the monomial f of x equals ax to the n power. If n is an even number and we have a positive coefficient, okay, so something like y equals 2x squared would be an example of this. Then we know the basic shape of the graph is going to be the shape shown here. We're going to have, in the case of an x squared, it's going to be a parabola. With an x to the fourth, it's not going to be a parabola, but it's going to be a similar shape. It would be just a little flatter on the bottom. And 6th power, 8th power, all of those are going to be the same basic shape. And so from that, we can talk about the characteristics of that graph just in general. We can look quickly at that graph and know that the domain is going to be negative infinity to infinity. The range, 0 to infinity, inclusive. The x and y intercepts, we just have both of them at 0, 0. The continuity, it's continuous for all real numbers. It's symmetric over the y-axis. It has a minimum of 0, 0. It's decreasing from negative infinity to 0, increasing 0 to infinity. And for the end behavior, the limit as x approaches negative infinity of the function is infinity, and the limit as x approaches infinity is also infinity. So all that just from a basic understanding of the shape of this function. If we change that just a little bit, and now we make the a negative value. So maybe we have a y equals negative 3x to the 4th power. Something along that line. Again, the basic shape is going to be the same. It's going to be, because of the negative, we know that's going to flip over the x-axis from what we had in the previous example. So we have this graph now. And again, we can go through and just look at the domain, range, x and y intercepts, continuity. All of those things come very quickly and naturally from knowing the graph. So those are two monomials with an even exponent. Now if we have an odd exponent, well, again, we're pretty familiar with what happens there. With an odd exponent, we know we're going to get this type of shape like we have with the basic cubic function. So maybe this would be, okay, we have n is odd, but a is positive, so maybe it's something like y equals 4x cubed. Okay. The details, again, are going to change, but the basic ideas all stay the same. So that we can look through it and very quickly determine, okay, the domain and range are both from negative infinity to infinity. X and y intercepts still at 0. It's continuous from negative infinity to infinity. Remember when we talk about that continuity, this is a range from negative infinity being an x value to infinity an x value. So we're talking about the domain going this way and this way. So it's continuous from negative infinity to infinity. It's symmetric through the origin. Remember that that's our f of negative x equals negative f of x idea. You can test that out here. There are no extrema. It's always increasing over its whole domain. And the end behavior now, as x goes to negative infinity, it's going to approach negative infinity. And as x goes to infinity, it approaches infinity. Likewise with n odd and a negative, so that might be something like y equals negative 5x to the 7th power. Basic shape is going to be the same, so the negative out in front is going to take what we had in the previous example and flip it over the x-axis. Domain and range stay negative infinity to infinity. The x and y intercepts don't change. Still continuous over its whole domain, or for all x in R. It's symmetric through the origin still. And no extrema, but our end behavior has switched. Now we have the limit as x goes to negative infinity of that function is going to be infinity, and the limit as x goes to infinity is negative infinity. So we can get all that information very quickly, and we didn't really have to think too much about it, just be able to sketch the rough graph of that. We can use that then to analyze a basic power function. So if we have f of x equals 1/2 x to the 6th, we want to describe the domain, range, intercepts, end behavior, all that stuff. So we're going to evaluate the function for several x values. Well, let's look at the graph first. We know that the basic graph of this, 1/2 x to the 6th, I can get pretty much just about everything I need just by thinking, oh, x to the 6th, so it's going to be something like that. And so looking at domain and range and all that stuff, we're going to see from the graph that the domain is going to be negative infinity to infinity. The range is going to be from 0 to infinity. X and y intercepts are both 0. That's y and y. X and y. End behavior. The limit, always talk about end behavior in terms of limits. As x approaches negative infinity of this function is going to be infinity. And likewise, the limit as x approaches infinity of this function will also be infinity. It's continuous over its domain, which is R. And it is decreasing from negative infinity to 0 and increasing from 0 to infinity. And here we have a table that shows us a little bit about the numbers in there. Did we really need the table to find all that information? No, just the rough sketch of the graph gave me that, but I can confirm that by kind of looking at the table. We want to do the same thing here now with f of x equals negative x to the 5th. So let's just make a rough sketch of the graph. It's going to be, let's see, we have the negative in front. So that's going to be starting up here, coming down, and it's an odd power. So it's going to go opposite directions on the left and right half. So looking at domain, we get negative infinity to infinity. Range, always dot your A, is going to be from negative infinity to infinity again. Intercepts, we have both x and y intercepts of 0. The end behavior, limit as x goes to negative infinity of this function is going to be infinity, and the limit as x goes to infinity is negative infinity. It's continuous over its domain, so it's continuous on R, or from negative infinity to infinity, and increasing, decreasing, it is decreasing on R, so over its domain again. So try this problem, and then work on page 92, numbers 1 through 6, which is part of your homework. We'll give you just a couple of minutes to get a few things done there before we take a look at the next section.